Hi there, it's Shannon, Math Chick Myers. I hope you're having a fabulous day. Now let's take a look at how we would test a claim about a population proportion P. So, what's the difference between constructing a confidence interval estimate for a population proportion and testing a claim about a population parameter? Remember, I know you can, it was in section 3.1 when we created the confidence interval estimate of the proportion of MiraCosta College students who vape. Our interval was 0.133 to 0.317, which indicated that with a 95% level of confidence, we conclude that between 13.3% and 31.7% of MiraCosta College students vape. When we constructed the interval, we used P hat, and in general, P hat is X over N for our point estimate, Q hat, which is 1 minus P hat, and N to find the standard error. So all information was from the what? Good, the sample statistics. Now, let's take a look at how we would test a claim about a population proportion where the sample distribution is a binomial distribution, which can be estimated using the normal distribution. Then, after that, we'll conduct a hypothesis test relating to the vaping example that we used previously. So here's some notation, all right? So N, of course, stands for what? The sample size, number of units in the sample, number of sampling units. P hat is X over N, number of successes over sample size. Now we're going to be introduced to this P0 business. P0 is the proportion assumed true under the null hypothesis. And then Q0 will just be 1 minus P0. And our test statistic, right? So we'll have this test statistic. And it's going to be P hat minus P0 all divided by the square root of P0 times Q0 over N. That's all under the radical. Good so far? Awesome. Well, notice here that unlike the confidence interval, the only sample statistic that we're using is this P hat right here. The other ones are the things that we're assuming to be true under this null hypothesis. All right, so here we go. Conditions, requirements. Okay, the sample observations are a simple random sample, or are from a simple random sample. The conditions for a binomial distribution are satisfied. So what does that mean? There have to be independent trials, right? So the probabilities don't change. Okay, so we got to make sure the conditions that NP are greater than 5. That's what it is in most textbooks, that NP and NQ should be greater than 5. you know, you can range between NP greater than 10 and NQ greater than 10, and this one here, okay, the 5s. It just really kind of depends on the text you're using and all that good stuff. We're going to go with 5 because most of the elementary statistics texts go with that. So we want to make sure they're both satisfied, so the binomial distribution of successes can be approximated by a normal distribution with mu equal to NP and sigma equal to the square root of NPQ. Cool? Now, always remember P0 is the assumed proportion. Used in the null hypothesis, it's not P hat. Cool, cool? Now, be aware that statistical software and graphing calculators usually require input consisting of the number of successes x and the sample size n. If you're given some fraction or percentage representing the sample proportion, you may need to solve for x like this. So we know that P hat equals x over n. So if we were to multiply both sides by n, do you see that this n would divide out and we would get a result of x is equal to n times P hat. Groovy? Okay, so let's check it out. So here we go. We're back to the vaping example, but we're expanding it. We're adding more info. So in a study conducted during fall 2016, it was found that 10% of MiraCosta College students vaped. You think that the proportion of MiraCosta College students who vape has increased. So during the fall 2018 semester, you decide to check it out. In a simple random sample of 80 MiraCosta College students, 18 of the students surveyed indicated that they vaped. At the 5% level, do you think the proportion of MiraCosta College students who vape has significantly increased? So here's certain things that should be involved. We want to figure out, okay, what's the null and what's the alternative hypothesis? Right? So the null hypothesis is always what is assumed to be true given past information, past studies, whatever. It's what you're checking out now. So here, the fact that this sentence here, you think that the proportion has increased, right? So sometimes it's easier to start with your alternative hypothesis. So the A stands for alternative. You'll see this sometimes as H1 or H capital, subcapital A. But we think that this proportion has increased, right? So this P0 in the problem is going to be what? Awesome. The 10%, which is equal to 0.1. That's going to make Q0 equal to 1 minus 0.1, which is 0.9. Good so far? All right, so let's go back and do our null and alternative hypotheses. So we think this is increased. Well, we're doing this comparison to the null. So we think that the proportion should be greater than 10% because we think it increased, right? Well, under the null, it is equal to 0.1. There are different schools of thought behind this. To be completely statistically correct, we would say P0 is less than or equal to 0.1 because you're supposed to make the converse statement to your alternative, or vice versa. If you do your null first, you do the converse statement for your alternative. The convention in a lot of books now is to always have a statement of equality for your null. So it's up to you. I'm going to go ahead and go with statistically super correct, but if you want this to be P0 equals 0.1, that's just fine. All right, so now let's find the test statistic. Well, we know this is the formula for our test statistic, right? So, by the way, you'll be provided with these formulas on the exam. So, Z is equal to P hat minus P0 divided by the square root of P0 times Q0 over N. Well, geez, we don't have all the info quite yet, do we? So let's go over here on our list, right? How could I find P hat? P hat equals, beautiful, X over N. So what information have we been given? In our survey of 80, right? So that would be N is 80, and I found that right here. Okay? So that'll be in all of these. And this is why we put the greater than, just so we can, because of the other blue highlight. And so now, let's check it out. What would my X be? Beautiful, 18, right? 18 of the students surveyed indicated that they vaped. That's going to be our success measure. So, this will equal to 18 over 80, and that's approximately it's actually exactly 0.225, and 18 and 80. Cool? Awesome. All right, so let's see. Are we missing any other info? No, I think we're good to go. So here we are. This will be equivalent to P hat was 0.225. P0 is 0.1 over the square root of P0 was 0.1. We found that Q0 was 0.9, right? Over 80. Well, when we do this on the calculator, we will get, remember to put parentheses around everything, so 0.225 minus 0.1 divided by the square root of 0.1 times 0.9 divided by 80. And we get approximately 3.73. Remember, with z-scores, we just go to the nearest hundredth. Okay, so now we have our test statistic. Now, we talked in the last video about 3 different kinds of methods we could use to test a claim. So I'm going to go ahead and do all of them. You need to know how to do all 3 methods, right, just to be on the safe side. So first, let's take a look at the critical value method. With the critical value method, remember that our confidence level, we want to use the 5% level, right? And so what that means, it means that, remember what that means? It means that, good, your alpha level is 5%, right? So alpha is equal to 5%, which is equal to 0.05, all right? So this is a one-sided test. So we are interested in one tail. And so what we do is we find our boundary value, the value that separates this into how many intervals? Good, 2 intervals. All right, so you can either use a table, right, or you could use your calculator. In this one, in the interest of, showing you the technology, I'll go ahead and use the calculator. All right, so with this one, we'll be using the inverse normal, all right? The area to the left of that tail, right, has to be, we have 5% alpha on that right tail, so what area has to be to the left? Beautiful, 0.95, because 1 minus 0.05 is 0.95. We're using the standard normal, so we're good to go. This is going to be 1.645. Okay, so remember, this is our z-scale, right? We're dealing with the standardized values, so this is 0, 1, 2, 3, -1, -2, -3. Our boundary value is 1.645. That's going to take us about here. Okay, so far? Awesome. .645. So the rejection region, if you will, rejection region is this region here. So when we use the critical value method, we will see where our test statistic falls. If our test statistic falls in the rejection region, we will reject the null hypothesis. Good so far? Awesome. So our test statistic was this one here, 3.73. Z equals 3.73. Do you see 3.73 would be way over here? That would be Z equal to 3.73. So do you see that that definitely lies in the rejection region? Okay. So what would we conclude? So just so you know, what we had found, that Z equal 1.645 was Z alpha equals Z 0.05, and that was equal to 1.645. Groovy? All right, so now this would lead us to, we'll do our final conclusion soon, but this leads us to the fact that we have it here. It being the test statistic means that we're going to reject the null. So in critical value land, that means reject the null. Okay? Now, in p-value method land, which is really probably the most common nowadays, p-values and confidence intervals, this is what we do. So now we are not using some z alpha value here. What we are doing is we are separating the interval by our test statistic, right? So remember, our test statistic was what, 3.73, which is way over here, right? And so here, what we're going to be looking at is, what is the probability that we get a value at least as extreme as our test statistic? So our p-value equals the probability that z is greater than 3.73. Okay. Second distribution, and then for our we would go to normal CDF. Okay, our lower bound was 3.73, comma, we'll just put something really big for our upper bound, I don't know, 1,000. And this is standard normal, so we're good. So look how little that number is. Or, you know, if you're doing it to 4 digits, you would have 0.0001. Okay? Well, how do you know if you reject it or not? Well, reject it meaning reject the null. Remember, here's where your alpha level comes in. So you compare p-value to alpha level. So 0.0001 is, how does it compare to 0.05? Beautiful. It's less than, right? So we reject the null. Okay? Confidence interval method. So in the previous section, you'll have to just go watch it if you never watched it. Actually, 2 sections ago, we found the confidence interval. I'll show you how to do it using the technology, all right? So utilizing the technology, what happened was, to get this confidence interval, we would go to stat, okay? And then in stat, we got to go to test. We will go to 1 proportion z interval, okay? And here are all the things. Actually, these are all the inputs we used last time for the 95% confidence interval, right? Now this, remember, gives us the interval of likely values, and it's using, it's creating this interval from our sample, okay? So none of the P0, Q0 stuff, it's all P hat, Q hat, etc. Okay, so just to recap, this is what happens. So when you go to the stat menu on your calculator, what you have going on is you want to select test, okay? So this next one represents the test menu, and on the test menu, we're doing a 1 proportion z interval, which is A. Okay? Then it jumps to this screen and you enter in your information. So see what I meant about the level of successes and stuff, or the number of successes? You need to enter in that amount, and then you get your intervals. So to the nearest thousandth, we get 0.133 and 0.317. So for our confidence interval, right, we get okay, so now what we look at is, all right, well, we have this interval of likely values, right? Well, in this interval of likely values, right, so if we start at, I don't know, this kind of a number line-ish, right? So 0, 1, we'll call this 0.5, right? So the interval of likely values that we created goes from 0.133, right, which is maybe here, to 0.317, which is maybe about here, right? So this is your interval of likely values, right? Well, where does our P0 land? Remember that P0 was, equal to 0.1, right? Well, 0.1, different color, 0.1 is going to be somewhere around here. And you see that's outside of the interval of likely values, right? So, again, we would reject the null. Since P0 is not inside the confidence interval. Now it changes if you have more than one proportion, but if you just have one proportion, that's how you can look at it. Groovy? Okay, so I've shown you 3 ways in which to reject the null. So let's make our conclusion, right? So many books do this incorrectly now. There are only 2 options. You reject the null hypothesis or you fail to reject the null hypothesis, okay? So when you're making your conclusion, you have to be really careful. One way that we can go about it is this, at the 5% level, sample data suggests that there is significant evidence to suggest that the true proportion of Maricosta College students who vape is not 10% or less. Okay? So, yeah, it sort of suggests that it's more now, right? But you don't accept the alternative. You just either reject or fail to reject the null. Okay? So we want to put our proper conclusion. Okay? And that is it. We're all done. Have a wonderful morning, evening, or afternoon, and I'll be talking to you soon. Bye.